Hi, today I'll solve this other problem from Bernoulli, and it says that in a tank we have water flowing at 0.3 meters cubed per minute, and the problem is asking us for the velocity of the water at the end of that tank, so at the top. And as we can see, this has a diameter of 5 centimeters and a height of 6 meters, and here a height of 1 meter and a diameter of 2 meters in the case of the inlet. And also is asking for the gas pressure at the top of the tank. And the water is entering at a pressure of 1 atmosphere. So we have to recall this equation of rate of flow. So the problem is saying us already the rate of flow. We only have to convert that rate of flow into the good unit, and you'll get 5 times 10 to the minus 3 meters cubed. I only made this conversion by with this equivalent factor, and then we only need to know the velocity too. In order to do this, we have to make this equal to pi times r squared times the velocity, and we only have to isolate the velocity from this equation. And always remember to convert your units. For example, this diameter I converted into meters, and then I divided into 2 in order to get the radius, and I substitute that value at my equation. And for the velocity, the second velocity at the top of the tank, we get 2.54 meters per second. And the second question is asking us for the gas pressure. In order to get the gas pressure, we have to use Bernoulli's. As always, gas pressure only means that our point of reference change, but in this case we'll keep it at this low level of the tank. Now by using Bernoulli's equation, we'll get the gas pressure. So pressure 1 is 1 atmosphere, and also we know the density of water. Also we know the gravity and the height, which is the first height of 1 meter, and also is the same density, and the velocity that we'll get it from the equation again. And the pressure, the second pressure is the gas pressure, the pressure at the top of the tank, the one that we want. We also have these values, the height, which is 6, and also these other values. So we are only missing this part of the first velocity, which is the same as we did with the second velocity, but we'll use the diameter of the first part of the tank. As always, remember to convert the diameter into meters, and then you'll get the radius. We got 15.91 meters per second for our first velocity. Now the only thing that is left is to isolate the second pressure, the gas pressure at the top of the tank. And also the problem is asking us to answer it in pascals. So 1 atmosphere is equal to 1.013 times 10 to the 5th pascals. And here is the value of the gush pressure at the top of the tank.